Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 3 of lesson number 9, Force and Laws of Motion. So I hope every one of you have revised part 2, because part 2 was the basic, introduction was done in part 1. Then I started the exact lesson in part 2, right, where we discussed on what is force. Then we discussed on different examples about the push and the pull, right? So we discussed so many things in the last class, and they were all basics about force. And then we started with the first law of motion. So we haven't completed that yet, right? So I'm going to continue with that first part that we have discussed. That is the first law of motion. We will revise it and then we will continue with it. And after that we have inertia and mass. And you might have seen, because I make you go through the whole lesson, you might have seen we have so many activities and examples to discuss in the lesson. So it's like lesser than the content, we have more examples which have been given, so we'll be discussing on them as well. Okay, for now, before I proceed with the further part of first law of motion, I want each one of you to please revise everything that we have studied so far. Whatever notes you have taken, I want you all to revise that. I hope every one of you are revising everything that you have taken a note of. So now I'm going to show you all the slides one by one, and I want each one of you to please go through it properly, because you will have it, you will have to use it some or the other how, and the force concept is like just a small part. So whenever you get to write a note on, you will have to include all the points. Okay, so make sure you know all the points and you're able to write it in your own words as well. I hope you all are going through it, and once while you go through it, make sure you even revise like what is push and pull, because if you remember in part 1 I have shared the thing with you. I have shared definition and all the important parts with respect to it, right? So make sure that you revise all of them and you know all of them. That is what is very important. That is the reason we are taking notes as well, right? Then we discussed on effect of force, and we can understand the effect of force on any object by the 4 points which have been given. That is by like the force can increase the speed of a moving object, it can stop the moving object, okay, it can like even increase and decrease the speed of the moving object, and then the effect of force changes the direction of the object, and it even changes the shape and size of the object. Okay, so these are the points that we need to be aware of. Then I hope like you all are going through it, and you know like this effects of force, what you can do is you can consider any one object and you can just check whether the effects are happening. You know it's like you will even understand how exactly it works, and you will know how it will go on. Okay, so if you do it, it will be like more beneficial for you. Okay, so I just want you all to please go through the effects of force, and then we will study revise the later part after this. After this we discussed that forces can be of two types. One can be like balanced force, and the other one can be unbalanced force, right? So what is balanced force now? When two forces are are equal, like you can say equal in size. Okay, Like I give you the best example to know about balanced and unbalanced force is that is of like tug of war, right? When we play that game, if the force is balanced, no one will win, right? So to win, one of the team has to apply more force. So in that case, it will become unbalanced, like either from one of the team, and whosoever will have the highest, like more amount of whosoever is going to apply more force is going to win, right? So I just want each one of you to please go through this slide as well. I hope every one of you all are going through it and even go through the example that they have given. Please go through each and every point properly so that you understand each and everything and you're not rectifying anything. See, if you haven't revised it, but if I ask you the question on it, you should be able to answer that as well. Okay, and how will you be able to answer that? Because you are aware of it, right? Because you know the concept, you can even like explain it with an example. If you can't give a proper you can say proper definition of it, like if you can see the definition has been given as a force where two forces of equal size act on a body in opposite direction. What is going to happen? A force where two forces of equal size act on a body in opposite direction is known as balanced force. So even though if you haven't revised it, you would be able to write this definition. It's just that you will be altering some or the other thing, right? But if you know the example, like it is going to become easier for you. So I just want each one of you to please like try to make your own answers as well now, because that is what plays a very important role again. Okay. After this, we discussed on unbalanced force in detail. So I want you all to please go through it quickly as well, because this is again very important for us, right? I hope every one of you are going through it and you even have the notes on it, because that is what I feel is very important. After this unbalanced force, we started discussing on first law of motion. So I want you all to please go through this slide as well. I hope every one of you are going through it. So here we have like about the inclinations of the slides that have been like given. So I want you all to go through that as well. Now we need to study from here, right? So I hope you're clear till here, because now we will be proceeding with the further part that we have, right? So see, Newton further studied Galileo's idea on force and motion and presented three fundamental laws that govern the motion of the object. Now here we have two names. One is of Newton, other is of Galileo, right? So Newton, like whatever doubts that Galileo had over here, if you have discussed or you might have revised, we discussed that Galileo argued that there's an argument of the Galileo that has been given, right? Galileo argued that when the marble is released from the left, it will roll down the slope and will go on the opposite side to the same height from which it was released. Right? So it was about the inclination part. And over here, what Newton did is, whatever argument Galileo had, Newton started studying on that. So Newton further studied Galileo's idea on force and motion. So whatever idea Galileo had on force and motion, everything was studied by Newton. And he, according to that, he presented three fundamental laws that govern the motion of the object. What did he presented? Three fundamental laws that govern the motion of the object. And these three laws that Newton came up with is known as Newton's law of motion. What do we know it as? Newton's law of motion. Okay, so we are going to study about all the three laws in detail, starting with the first law of motion. The first law of motion states that an object remain in state or rest or of uniform motion in a straight line unless compelled to change that state by an applied force. In short, if I say all the object around you will continue to remain in the state of rest, it won't move, it will be stationary throughout unless and until you're not applying any external force on it, right? So in other words, all objects resist a change in their state of motion. What happens? All the objects around us, they resist a change in their state of motion. So in a qualitative way, like we are not talking about the quantity, we are talking about the qualitative way, means the quality. So the tendency of the undisturbed object to stay at rest or to keep moving with the same velocity is called inertia. Okay, what happens? In a qualitative way, the tendency of undisturbed object means the object is at rest, the object is not moving. So the tendency of that object to keep moving with the same velocity, we call it as inertia. See, whenever it comes to first law of motion, inertia is going to be in the picture because it is like related to inertia itself, and that is why the first law of motion, we also call it as law of inertia. So don't get confused, or like don't get confused like if they ask you to write a note on law of inertia. Okay, it's one and the same. The first law of motion is also called as law of inertia. Okay, so certain experiences that we come across while traveling in a motor car can be explained on the basis of law of inertia. Now, many experiences we have, like while we are traveling in a motor car or traveling anywhere, we can explain everything on the basis of inertia. So, we tend to remain, like suppose you are sitting inside the car, you are sitting like comfortably on the, like inside the car, right? But you're moving. So, you are at rest, but the car is moving, right? So, we tend to remain at rest with respect to the seat until the driver applies a braking force to stop the motor car. So unless and until the driver is not applying any brake, you're going to be like stable, and you will be like stationary on your seat, right? So with the application of brake, the car slows down, but our body tends to continue in the same state of motion, right? If the brake has been applied and the car slows down, still in that case our body is going to be in the same state of motion because of inertia. Got it? The car is slowing down, but we are not slowing down. We are still at rest. Why is it so? Because of inertia. Even if the speed of the car is increased, then too our position will remain the same, right? So why is it so? This is again because of inertia. Okay. So a sudden application of brakes may thus cause injury to us by impact or collision with the panels in the front. So the panels that we have in the front, if the driver applies a certain brake, okay, what can happen? We can have injury, and that can lead to have an impact or collision, right? So that is not good for us because we can get collided with the panel that we have in front of the car, like, right? So safety belts are worn to prevent such accidents, and safety belts exerts a force on our body to make the body motion, like to make the forward motion slower, right? Why do we wear a seat belt? We know that seat belt is very car, like is compulsory when it comes to sitting inside the car and traveling through it, right? So safety belts play a very important role because they are going to exert a force on our body to make the forward motion slower. And opposite experience is encountered when we are standing in a bus and the bus begins to move suddenly. Just imagine that you're standing like somewhere in the center of the bus and the bus starts suddenly. Now we tend to fall backward, right? Why is it so? Why do we tend to fall backward? Because the sudden start of the bus brings motion to the bus as well as our feet in contact with the floor of the bus. So that is the reason that we tend to fall backward in this case. Okay. So here we have like very good examples that they have given us. I want each one of you to please go through it quickly, like through all the examples that they have given. Or let me just discuss this as well. See, but the rest of our body opposes this motion. Now our feet, you will like go backward, but your whole body is going to resist this motion, and that is because of inertia. Okay, so when a motor car makes a sharp turn at a high speed, just imagine you're sitting inside the car and the car takes a sharp turn, and that too at a high speed. We tend to get thrown to one side, right? To either to your left or to your right. You are going to go to the one side, right? So this can again be explained on the basis of law of inertia. How can we explain it now? On the basis of law of inertia, and we tend to continue in our straight line motion when an unbalanced force is applied by the engine to change the direction of motion of the motor car. Okay, whenever there's going to be an unbalanced force, and when an unbalanced force is applied by the engine, it is going to change the direction of motion of the motor car, and because of which we sleep to one side of the seat due to inertia of our body. Okay, so the fact that a body will remain at rest unless acted upon, okay, unless acted upon by an unbalanced force, can be illustrated through the following activity. So we have this 9.1, 9.2, 9.3 activity, which is going to make us understand about like the unbalanced force. So I just want you all to please go through this slide properly. I hope you all are going through the example. I'm showing you. I told you to read this for a reason so that you will understand it well. So make sure you all are reading it. You have to even take notes of it. So make sure you're doing that as well. After this, we will be even discussing the activities, but make sure whatever like points have been given over here and the examples which have been explained, you have understood them and you're not rectifying them, because like you don't have to do that as well. So whenever you have been asked to write a note on first law of inertia, you have to include all those points. I hope every one of you are like writing the examples and about the first law of motion, what does it exactly states. You need to even include that it is also known as law of inertia. Here also we have some of the points which have been given. So I want each one of you to please go through it as well. See, now here we have like three different activities to discuss. Let's see what exactly they are. So for this activity 9.1, we need to make a pile of similar carom coins on a table as shown in figure 9.6. Okay. After that, we need to attempt a sharp horizontal hit. Okay, attempt a sharp horizontal hit at the bottom of the pile using another carom coin or the striker. So like the striker that we use normally, we need to do the same thing. Okay, after that, if the heat is strong enough, the bottom coin moves out quickly. What will happen if the heat will be strong enough? The bottom coin moves out quickly, and once the lowest coin is removed, inertia of the coin makes them fall vertically on the table. So that is the reason why does it falls, right? So the reason is because of inertia. Now suppose you have like you had a pile, you made a pile of the coin, and why will it like fall down? Because of the inertia. Once you remove the last coil, it breaks down and and sometimes that is what we want while we are playing, right? That it should fall like beside us, wherever from where from whatsoever end like it is happening, right? So you can just explain this activity in your own words in your book. I hope you all are explaining it in your own words. After this, the next activity that we have is 9.2. See, set a 5 rupee coin on a stiff card covering an empty glass tumbler standing on a table as shown. So the glass that you need to take is should be empty. You need to put one like card on the top of it, and you have to keep a coin on it, 5 rupee coin. Okay. After that, give the card a shape sharp horizontal flick with a finger. What will you do? We need to give the card a sharp horizontal flick with a finger, and if we do it fast, then the card shoots away, allowing the coin to fall vertically into the glass tumbler due to its inertia. So when we flip that, when you flick the card, what will happen? The coin will fall inside the glass, and the reason behind that is because of inertia. So the inertia of the coin tries to maintain its states of rest even when the card flows off. Okay, what I said? The inertia of the coin tries to maintain its state of rest even when the card flows off. So I want you all to please go through it quickly. You have to explain the activity in your own words in your book. After this, the last activity that we have is, what you need to do is place a water filled tumbler on a tray. Okay, it should be a water filled tumbler. Then hold the tray and turn around as fast as you can. What will you do? You're going to hold the tray and turn it round as fast as possible. After that, we observe that the water spills. Now, what do you think? What is the reason for that spill of the water? Because if you observe it, the groove is provided in a saucer for placing the tea cup, and it prevents the cup from toppling over in case of certain jugs. Now, I hope every one of you might have gone through it, right? I hope you all are writing this as well in your book. You can explain the activity in your own words. It's not that you need to write the same thing. Okay? You have to explain it in your own words. So there were three activities just to explain you about inertia, right? Because the first Newton's law itself is law of inertia, which is also known as the first law of motion. after this 9.3, like after discussing on the first law, okay, that is law of inertia. Now the next thing that we are going to study about is the second law of motion, but before that we have one small concept that is on inertia and mass. So here they are explaining us the same example that we were discussing about the seat belt and the brake applied by the driver, right? So we'll be discussing on inertia and mass in detail, and after that we have the second law of motion that we will start with in the next part. Okay, now this is also going to be a huge part, and under the second law of motion we have mathematical formulation of second law of motion that has been given, and this derivation we will be discussing on, like we will discuss this in detail as well, and then we will discuss more about the second law through an example. Not only one example, like there are 2 3 examples that have been given on the screen, like example 9.1, then we have example 9.2, 9.3, 9.4, 9.5. So total 5 examples on just the second law of motion. So just imagine, like what exactly or how important the second law of motion is, right? So after discussing these 5 examples, we have the third law of motion, that is the last law, that every action has equal and opposite reaction. Now this is the most famous law. Okay, so we'll be discussing on third law of motion in detail. Then we have this activity 9.4 to understand the concept of third law of motion. We will be discussing on conservation of mass in detail. Sorry, conservation of momentum in detail. After that we'll discuss on activity 9.5 in detail, like what exactly the third law of motion states. Like we will be discussing it through 2 3 activities. Then again we have few examples to correlate and study, you can say, the third law. So we'll be just doing all the three, so there are 3 different examples given. And after that we have the summary discussion, like what exactly we have discussed in the whole lesson, we'll do that. And then we have some exercise questions to discuss as well. We'll be doing that as well. So I'm going to show you the questions one by one, and I want each one of you to please go through it quickly. I hope you all are going through the question. So there are many questions in the lesson, which we will be discussing them all at the end of the lesson as well. So make sure that whatever we discussed today, you revise it properly, okay? And after that, like we will be continuing with the further part for the lesson, force and laws of motion. Okay, so I'll end this part over here, but make sure you keep on revising it because there are total 18 questions later to discuss, right? So I'll end this part. Thank you, everyone.